Your professor and mentors. Here is group 6, and we are going to show the demo video for the level 7. Firstly, we followed the instruction to create a Amazon Linux 2 AMI EC2 instance using C5 the large instance and set up the security group rules and set up the HDD space, but because I cannot show the instance to you because it has been terminated by me after finishing the whole PySpark experiment. But I can show you the terminal, the setup, and the notebook code. So let me show you how I set up the PySpark environment. Firstly, use the sudo service dog start. No. Firstly, I just SSH to that instance. I named the instance EC2-user, and then I just update. Then I use install Docker, the Docker. Then I use Docker run. Then I start Docker and run here to connect this folder to this folder. So here the PySpark has been installed, and I use the log to see the name, and I use this link to access the notebook and to code. But because I already terminated this EC2 instance, so I cannot access this notebook again. So after doing this, I followed the instruction, and I followed the whole instruction. Firstly, introduce the Spark context and give it some data and show data and do the mapped data and squared the data and introduce circle context and introduce some data structure and parallelize and create the data frame, print the schema, and read the data from this link. Use circle context and read the data and show the data scheme. And as you can see, it infer the scheme right, because it not only has the integer type but also has the string type. And I just show the data, and also here follow the instruction. It shows the wrong schema because this file name is wrong. No, because we are not we don't use this infer schema, so all of the type of this data is string, so it's wrong. And here, let me see, we just convert this data into float type by using this function, because to train this data with machine learning, we need to convert the type of the data to float instead of the string, and introduce the machine learning frame and print the schema again and show some data, and then group by the data and course type data and drop the data we don't want to use and filter group by. And here we just introduce all of the packages from this folder, and we just squared the age. And here we check if we square the age correctly. We found yes. And here let's do the one-hot encoder and do the string indexer and a vector assembler. So here we do this now, as you can see here. And we just assemble the feature into a vector named features. And so the training data consists of label and the features. As you can see here, we showed two row of the data, and we split the data into training data and the test data, and we just see the training data, and here is the test data. And we do logistic regression mode, and we train this data 10 times, and the regression parameter equal to 0.3, and we feed the data into the model and get the linear model, and we print the coefficients. And we just use the linear model to see the predictions of the test data. Also, we print the schema of the predictions. As you can see, label, features, row, prediction, probability, and prediction. And we select label and prediction and the probability, these three to print 20 rows. As you can see, the label, the test data, the label is 0 and the prediction is 0 and the probability is 0.9489 is pretty good. And here we group by the label here, and we write a function to calculate the correction rate is 0.8265, and also we introduce ROC to see the correction rate is 88% around. And also we tune this model by introduce two parameter. The first is 0.01. The second one is 0.5. And we train this model again, and it takes 422 seconds. And we get the accuracy of the model is 84.941%. Yeah, that's all. So we finished the first task to just get familiar with PySpark, and then I downloaded this data set from UCI, and I just run the PySpark on the Docker locally, and just train this data in the using PySpark. And here, let me show you. Here, I using Docker run here to connect this is where the data is. Connect this folder to Jupyter PySpark notebook to this folder to let the PySpark can read the data from this folder. And I get this link. By click this link, I can access the notebook to create a machine learning model to train the data. Yeah, these are the training. Okay, but there is one thing. I also cannot access the notebook. I don't know for what reason. For example, let me show. But before that, let me show you the Docker. It's in use, created 8 hours ago, and the containers is running. Yeah. But I cannot access it again for this reason. I haven't solved it. I don't know why. It asked me to enter the password or token, but I don't have both of them. I try to use this token, but it doesn't work. But it doesn't matter. I have finished all the code, and I get the accuracy rate both for training data and the test data, and got the F1 value. And here is the code. And I also use this code for the next task to train this data on the EMR using S3, using clusters, using the workspace on Amazon. But let me introduce this code to you first, although we cannot access the notebook. What a pity. Yeah. Firstly, introduce this package and create two schema and read the test data and the training data and also give each row an ID from using monotonically increasing ID. And here we just combine the features and the label, and we assign the label the features into a feature vector named features, and we drop those features. So and we print the schema to see if the training data just consists of the two data. One is label, the second one is features. But yes, the answer is yes. And here we just training the data 10 times and feed the data into the model and get the model and get the prediction. And here we get the training data prediction and the test data prediction. And here we just want to see the probability, predict probability, and we show the label, the prediction, and the probability, and then we just use ROC to see the value, and also use ROC to see the F1 value for training data and test data. And lastly, we just print this. Because the data, because the code is the same with the next part code. So let me show you. Let me show you the answer here. Yes, here is. Firstly, we see the training data just consists of label and features. The features is a vector, consists of a lot of the 561 features. And here is the prediction, also label and features. And we get the predict probability, which is here, represents the probability of the prediction. The label is 5, prediction 5, the probability is 97.9%. And here we print 20 rows of the prediction, which seems good. And the training accuracy is 93, almost 94%, but the test accuracy is only 87.58%, and the training F1 score go to 0.9367, but the training F1 score is only 0.8735. So here is the first part of level 7, first part PySpark. Then let's go to the second part. Second part, firstly, I created, let me show you. I created a S3 bucket. And here I named it E542 Lab 7 Group 6. And I upload the test data here, training data here. It takes so long to upload these two files, especially the xtest.txt file. It only 33 megabytes, but it takes around 20 minutes to upload this. And also the training data here. After doing this, I also added here. Let me see the permission. Yes, I blocked. I changed it to off. I don't want it block all public access because I don't want there will be any accident that I cannot access S3 bucket. Yeah, I think that's all the configuration about S3 bucket. Then I just okay. Then I want to create a notebook, but I found Amazon changed something to create a notebook. I need to create firstly I need to create a studio. But before creating a studio, I need to create some roles and create a IAM user here. I created a IAM user named Haoyu, which is my name, and I add this permission to it. It's EC2 for access, S3 for access, and the elastic map reduce for access and those. And also I create a roles. Why I should create this user? Because to use the kernel, to use the kernel in the PySpark, we need to create this IAM user. And to create the studio, the studio, I need to create the roles. I think this roles is level 7. Yeah. Also I add these policies to it as 3 VPC, EMR, and EC2 for access. Okay, after creating the roles, I can create the studio. As you can see, I just choose the S3 bucket. I attach this S3 bucket to this studio, and I use this role studio service role. I use level 7, and the VPC is I created for level 6 or something, and the subnet I just choose one subnet in this VPC randomly. And here is a big point. The security group, for the security group, I used, actually it's not default security group. Here, let me show you. There are two security group I need to attach it. The first one is here, the second one is here. This one is for the I forgot. This one is for the master, and this one is for the slavery, or this one is for masters for slavery. Okay, never mind. Let's go to these two security group. I think this group here. The first one is the last digit is 2DA. 2DA for 2DA, I just firstly inbound rules. Inbound rules here is the key point. I just allow the TCP traffic through port 1888, and the source address is the other security group, and outbound rules is all traffic for to the other security group, and this is the other one. Inbound rules, we cannot have any ingress rules. If we have any inbound rules, we cannot create the notebook. And for the outbound rules, the only rules we can add is the allow TCP traffic through this port to the security group we talked about earlier before. So this is the two security group we need to take care of. Let's go back. So after add these two security group, we created this studio. And after creating the studio, let's create the clusters. Here, I just created a lot of clusters and terminate them. For the clusters, what I should do is just follow the instruction. Firstly, use this S3 bucket, which is the one we created before, and choose the key level 2, and choose the VPC, which is the same with the studios, and also the subnet. Let me, oh yes, here, just use these two security group. I think these two security group are created by itself. Yeah, and we use, oh, of course we use the most updated EMR, and also use the instance, the type of the instance. I forgot. I just follow the instruction. Okay, never mind. After creating the cluster, we need to create the notebook here. Create a notebook, and after created, we it will open a here a notebook for us automatically, and here we could attach the cluster we created before to our notebook. Here I already attached it to the notebook, and we just copy this code we used before for the first part of the level 7, the model I created before for the UCI data. Just copy it and run this code, and we can see there are two nodes are working on this maybe, and it takes a little bit of time to train the data and test, and this is the results we have seen before. So this is the second part of level 7. Okay, for the third part, custom Spark program. Firstly, I just upload that file I downloaded from the link provided in the instruction. I just upload that file into the S3 onto S3 bucket group 6 and see here. Upload it here and also do the same thing like create here. Create a studio and in the studio created a notebook and attached the cluster to that book. It's a 2-node cluster and this is the studio. You can see here is the cluster I attached to this notebook. And here, let me explain the code. Firstly, we filter the character between 33 and the 122, and we just read line by line and split the word uh, by the space and count the word. And for the character frequency count, we just count the character between 33 and 122, count them, and yeah, that's it. And here we get the minimum number of the word, min number, maximum of the word, and get the minimum character, maximum character, and print them out. And here we just create a structure named output to combine those results and write the result and save into a file and save that file named word and character count.txt. Save this file in S3 bucket. As you can see, here are the jobs done by the node. And also we print out the output. As you can see, here is the word count and a lot of words. Okay, let's go to the deal word count. Oh, I'm sorry, it's stuck. Okay, I'm sorry. It's stuck. So I only showed the result in the here. Let's just go to the S3 bucket. Go to S3 bucket, and here, as I mentioned before, I saved the output here and success and the part here. Just open it. Okay, yeah. Here is the word count and word count, and okay, and the character count. As you can see, here are the character count, and here are the result. And for the scalability of these three, I for the by search the materials on the Google, I found Spark has the highest scalability. Yeah, Hadoop, the scalability of Hadoop is in the medium, and the scalability of MPI is depends, and usually is low. Is the lowest one. And when the number of the nodes increases, the performance of the Spark will increase more than the other two.